Hey, welcome back everybody. Today on my channel we are going to tear down and rebuild a 230 cubic inch Plymouth Flathead or Flathead engine. I've been wanting to do one of these for a long time, and it just so happens that we have a customer that has one. So this engine I believe is from 1936. So for those of you that are into flatheads, you are going to love this video. We're going to take this dirty, greasy, nasty flathead, completely rebuild it, update it, and put some aftermarket parts on it, put an aluminum head on it, some Offenhauser parts and so forth. So let's get started. The first portion of the build consists of taking off a lot of these dirty, greasy, nasty old parts. What's cool about this is some of the performance chains of today have a double roller set of chains and gears. Well, this thing has a double roller on it. Actually, I don't know if it's a double roller, but it's definitely a double link chain. So one of the things that's noticeable is the oil pump pickup screen is actually screwed on to like the center main cap. It's kind of cool, and then it has an oil feed tube that goes up to it. Some of the engineering they had back then was pretty interesting. The nice thing about this engine is it does have bearing inserts in it. Some of these were what they call pour and bore, which would have been a lot more work. But the nice thing about the Chrysler or Plymouth engine is most of them had bearing inserts in it. So that's going to make this job definitely a lot easier for us. So the next step in the disassembly process is we're going to take the piston and rod assemblies out of this thing. There's the bearing insert for the connecting rod. Man, these old engines with this non-detergent oil were really nasty. They just had really nasty, sludgy oil in them. So there's our first piston. What was interesting about these pistons is a lot of these old pistons had 4 rings on them. They had a couple of compression rings and then 2 oil rings, and they had a C-clip in them, and they were full floaters, and they had this big long connecting rod. Really interesting type engine. This one is showing a little bit of wear, and also they had a slit in the piston for clearance. It was like a heat dam, which was designed for expansion and contraction. That's how they dealt with it. Today they make pistons, the configuration of the pistons is completely round and they're egg-shaped. Back then they made them round and they put a heat dam for expansion. And this piston here actually has a part number on it, which is pretty interesting. It says Silverlight 1201. I'm not sure if that's a factory piston or if that's aftermarket. We'll have to look into it and find out. Stuff this old, I mean, sometimes the aftermarket companies actually made pistons for Mopar, Chrysler, GM, or whoever, but we don't know. More than likely something this old has probably actually been rebuilt. And on the other side, which is kind of cool, it says heat treated. So it literally has heat treated kind of written into the cast into the piston there, and on this side it says Silverlight 1201. That's kind of a neat deal. You don't really see that too often. So yeah, really neat. We'll get the rest of these out and look at the situation with this engine. There is a stamped number on the side of this motor, and I'm going to try to decipher that later. I did look into that earlier online, and there's a bunch of different, there's probably, I don't know, 30 or 40 different numbers that they stamped on these blocks, and they put a letter and a series of numbers, and that helps you decipher what the engine was in, what year it is, and the size of it. We believe this is a 230, but we're actually not 100% sure on this at this point, at least I'm not. So yeah, I'll get the rest of this apart and then we'll take a look at it, what we have, get it cleaned up and get going. Okay guys, so as you can see, we've got the piston and rod assemblies and the crankshaft out of our little Plymouth here. When you look into the bottom end of the Plymouth, or the Chrysler, or whatever you want to call it, it's notable that the thrust bearing is actually the rear bearing in the engine, and you will find a rope seal back here. That's a rope seal in there. The camshaft and the valve train is actually in the block. You'll notice that the oil pump bolts into the side of the block and it meshes with the gear on the cam, and the cam actually drives the oil pump. So the next step is to get the oil pump out, and then we're going to lay this over on its side, and I want to talk to you about how we get the valve train out of this engine, because it's a little bit tricky. Not too bad if you know the right procedure, but we do have to get the valves and springs and so forth out, because we're going to rebuild all that portion of the engine as well. So like I said, pulling the oil pump's real simple. It's just a couple of bolts, and this goes into this bore here, and this is the pump. Now we're going to replace this pump. We may take it apart and inspect the condition of it, but for now we're just going to set it aside because we're planning on putting a new pump on this engine. Once you get that out, now we can take a look at the valve train on this thing. So like I said, on the Flathead, most of you know, and some of you don't know, that the valves and the springs are actually located in the block. And so there's a procedure for actually getting those out, because we're going to rebuild the valve train on this. We're going to put new valves and springs in it. We're going to put new guides in. We're actually going to set this up on a machine later on in the video. Once everything is checked out and vatted and cleaned up and we start the machining process, we're actually going to put hardened exhaust seats in this block for our exhaust seats, so this engine will be compatible with unleaded fuel. So let's get started on disassembling this valve train. So what you'll notice on the valve train, guys, is that you have some adjusters in here, and what the service manual recommends is that you adjust these all the way back so that there's some play in here, and that way you can get to the valves and springs on this. And also they recommend that you rotate the camshaft as well and get these valves off of the lobe of the cam. Now these two here, we're going to start with these because these two lifters, I've rotated the cam and they are actually off of the lobe of the cam. They're on the base circle or the heel of the cam, and so we can actually change this adjustment here. And the way that you do that is with a couple of wrenches. So all you need to do this is a couple of wrenches. There's a slot on the lifter itself here, and you can see this is moving. The slot on the lifter takes a 1/2 inch wrench, and then the adjusting nut that's on here just takes a 1/2 inch wrench. And then we're just going to adjust that down. It's kind of a self-locking deal, so you just want to adjust that down till it's loosened up. And that's going to give you plenty of clearance to get your spring compressor on here, so that you can. And these are a solid adjustment here, so they have lash to begin with. So if I run that adjuster down all the way, the adjuster is actually built into the lifter, which is kind of a cool deal. And we're gonna replace these lifters with a reground. The customer has a custom ground cam and some reground lifters that he got from Aggie out in California. Some of you may have heard of Aggie Machine Corp. It's one of the biggest suppliers for stuff like this. If you're building some of this vintage stuff, it's a great company. So you can see we got a big gap there. See the lifter moving back and forth? We ran that adjuster all the way down, and now we're going to take our spring compressor and we're going to compress that spring, and we're going to get that spring out there. And then we'll be able to pull our valve out. Okay guys, so at that point, now we can get our spring compressor on it. You got to have a spring compressor to do this, and if you don't have one, most of the time the local machine shop can take this apart for you. So now that we've got that compressed, we just take a magnet and you can get those keepers off there. There's your keeper, and those keepers should come off fairly easy. If they don't, just kind of pry them off of there. There's a lot of gunk and sludge stuck on there. So there's our keepers right there. And now we're just going to take the compressor off, and you should be able to pretty easily get that valve out of there. the valve is free, so this is one of our valves, and of course we're gonna replace these. So now that your valve and your keeper is out of there, you can just take and kind of work that spring and retainer out of there with a screwdriver. It's fairly easy to do at this point. You just kind of move it over to one side, and there's your spring retainer and your valve spring. And then of course we're just going to repeat that for all of these. We're going to take this valve train apart. Again, as usual, I won't insult your intelligence by making you watch me take every one of these out, but hopefully that gives you a little insight. I'll get these out, and once we get this valve train apart, then the block is pretty much disassembled. We do have a few plugs and so forth that we have to get out, but we'll deal with that when we come back and get this valve train out. Okay guys, so we've got all of the valve train components out. Now normally I would keep these in order, but we're replacing all this stuff, so it doesn't really matter in this situation. But if you are going to regrind or recut the valves, you want to keep that in order. Now we look at the front of the engine, and there's a little oiling tube here that you take off with. It takes a flathead screwdriver. So you want to get this off. And this little tube comes out of the block here. It has a little tab on it, and this is a little oiling tab. It basically looks like that. This portion goes into the block, and the screw holds it in here. And it's just a little oiling tube for the front of the motor there. And you want to make sure you hang on to that screw too that goes with it. We'll set those aside, clean them up. Now the cam itself has a retaining plate, a couple of retaining bolts. We've got those loose already, so we'll remove the retaining plate. Now that we've got the valve train disassembled, you should be able to just very gently slide this cam out. Now, we're not going to reuse the cam here. This piece on some of these is pressed on. I believe this one is. So on the new cam, we're going to have to press this hub off and get our retaining plate off. Sometimes the new cam will come with this piece, depends on where you buy it from. But we definitely don't want to discard this stuff. We want to save it. These camshafts can be reground in most cases. They'll regrind these and reuse them. There's really not a lot of actual new cams available for these. There is a few sources for them, but very often we will regrind the old cam. In this case, the customer has a new camshaft that he's purchased for this thing, so we definitely want to save this and set it aside for these pieces here. Don't discard this. At that point now, we've got our lifters in here, and you can see we can just pull our lifters right out of that bore. And you want to hang on to these lifters too, because this is a solid lifter. It has the adjuster on top of it. You want to hang on to these because very often you can get these recut or reground. You want to save these because they're reusable once we regrind them. Even if we don't use them on this motor, we'll save them. We may need this cam for another engine down the road or something. So definitely want to hang on to the lifters. So I'll get all the lifters out, and then we'll come back and look at the bare block and talk a little more about that. Alright guys, so we've got our 201 cubic inch flathead torn down. We got the crank, this is the valve train parts, and I've got all the lower end engines in this tote here. And man, when you tear one of these down, they use this old non-detergent oil in these things, and it is a really big mess to tear this down. I think I spent as much time cleaning up the teardown area as I did tearing it down. So we've got our block strip, we've got all of the core plugs and gallery plugs, and everything is out of the block. I am going to have to pull these studs because we're going to have to resurface this block, and also we're going to have to set it up and put hardened seats in here. So But I'm going to go ahead and take it down and vat it first. It's just so nasty, I don't really want to even work on it anymore this way. So we're going to take it down and we are going to vat this turkey. So once I get all this stuff cleaned up, then we'll start taking a better look at this block and so forth, and we'll get a better idea of where we're at. So I will see you back here when I get that done. Okay guys, so we got the block back after we vatted it. I brought it back down here. We vatted all these components, got them cleaned up. Another thing that we want to do on the block, and I've already done it, but I'll just demonstrate it. This tool here is a Magnaflux Er, and we have magnetic powder. And you can see there's magnetic powder all over. Basically, we use a magnetic field and we sprinkle mag powder on this, pretty much over the whole block, on all these surfaces here, like so. And I've already, what happens is when you Magnaflux it, this magnetic powder, if there's a crack, the magnet will pull the powder into a crack. So we've Magnafluxed this entire block, and we're pleasantly surprised to find out that there are not any cracks in this block. So, you know, when you deal with something from 1937, you never know. The bore itself on the block is already 30 over, and we got a pretty substantial ridge, but we put a bore gauge in here, and we discovered that we're going to be able to go to about 60 thousandths oversized, so we're going to order pistons for that. So the one snag that we did run into here was our crankshaft. The crank's not bad, but we got back here to where the thrust flange is, and this thrust flange, if you can see it, it's wafer thin right there. It's almost a sharp edge, and we got tons of wear here. So what has happened is the thrust flange area of the crank is wiped out, which means unfortunately this crank is pretty much junk. We could get this repaired and welded up, but it's about 800 bucks to do so. I actually found another crank for less than that, so we are going to be purchasing a freshly remanned crank for it. But what we're going to do is we're going to look at the warpage to make sure that the top of the block is straight. So we're going to take a straight edge and a set of feeler gauges with our straight edge. Now this is a precision machine straight edge. It's not just some random piece of steel, it's a straight edge. And so we'll take that and our feeler gauges and we'll check this. Now the service manual for this engine says that you can't have any more than 3 thousandths warpage in a 6-inch span. I go a little further than that, and I use a 2 thousandths blade because I want to make sure we have this thing absolutely flat. So what we've noticed is, and I checked this earlier, but it definitely has some warpage here. The blade, the feeler gauge is sliding under several of these points. That's a 2 thousandths blade. And then of course you want to go diagonally this way to make sure that the block is not twisted, and it definitely is. We definitely got some twistage and a little bit of warpage. So we were going to pull the studs anyway and replace them. So we know for sure that we're going to have to resurface this block once we get the studs pulled out. Okay, so now the next thing is we got to start looking at the cylinder bore. Now what I have here is, this is a dial bore gauge, and you can get one of these anywhere. We got this at Powerhouse. I've got the dial bore gauge here set for my bore size, actually set for my bore size plus 30, because this block, we did discover that it's already been rebuilt once. It's been bored 30 thousandths over. So we've got our dial indicator set for 30 over here, and we're just going to go ahead, and I've already checked it, but what I found was pretty incredible. There's a big ridge at the top. You can actually feel it with your fingernail. So if you can feel a ridge up here with your fingernail, which we can, that is a big indicator that you have a little bit of a problem here. Once we get down below that, so keep in mind 0 on the indicator, go to the smallest point. 0 on the indicator here is the size the bore should be, and right there on that one we have about, I don't know, 15, 16 thousandths wear. That's a lot of wear. Fortunately, we can get 60 over pistons. I called Aggie in California, and they have 60 over pistons for this engine, so we can get the pistons to take this block 60 over. So those are definitely two courses of action that we're going to take with this block. Now we've verified that there's no cracks in it. We have looked at the bore and made the determination that we got to bore it to 60 over, and also we're going to have to deck the surface here. So the next step is checking the alignment on the bottom of the block, and I'll show you how we do that. To check main bearing bore alignment, and that's alignment is making sure that the mains are in a perfectly straight line with each other. We're just going to take our straight edge again and we're going to set it right in the main bore here. Once we get it set in the main bore, we're going to take our smallest filler gauge, which is 1.5 thousandths, and we want to make sure that that doesn't slide easily under this straight edge at any point. And if it pulls the straight edge like that, you're okay. Our alignment is actually pretty good on this motor. We don't have any signs of this small feeler gauge going underneath at any point, and you want to check it at several points here. We're checking several places on the bore, and the alignment's really good on this motor. I don't see any issues with this. And then the next thing you want to do, which I've already done, I did it off camera, is the size of this bore is pretty critical too. So you want to take your cap, put your cap on, torque it down, and put a bore gauge in there. I did that off camera. The main bores are really straight on this. I didn't spend a lot of, I didn't bother filming it because that's not really something you're going to do if you build this. It's kind of a machine shop deal. Just have them check this bore down here and make sure it's round. They turned out really nice on this block. This is a pretty low RPM, low horsepower deal, so generally what you find on these older engines is the main bores usually don't have any kind of outer round or taper, especially considering the fact that the Chrysler had 4 main caps. A lot of these early blocks only had 3 mains. They had one in the back, one in the middle, and one here. So the Mopar, the Chrysler inline 6 was actually a more durable, sturdy engine, and the mains seemed like they held up really well. Okay, now the next thing, let's look at the valve guides. So the next thing we want to look at, we've got all the valves cleaned up here, and this is just one of the old valves. You want to mic the valve stem, and we're going to replace these valves, so I didn't spend a lot of time on this. They do show signs of wear. But another thing I noticed is if we put the valve in here, the guides are real sloppy on this. It's moving all over the place. So we're definitely going to want to replace the valve guides. We're going to get the new guide inserts, and when we get this set up on the machine, we're going to drive those out, install new guides while we do our valve job. So that's our course of action. Basically, the only other machine work that we're going to do, we're going to reuse these connecting rods. We're obviously not going to reuse the piston. There is a bushing up in the small end here, a bronze bushing that goes with that pin. We're going to get new pistons, new pins, and new bushings. We're going to put new bushings in and fit the pins to the bushing. And also on the big end of the rod, we're going to put new rod bolts and nuts in here, and then we're going to resize or rehone these out. We're going to shave the caps and have the rods resized, and of course we're going to Magnaflux them to make sure they're good. I don't anticipate them being bad because this engine looks pretty good. And there's not a lot of stress on these because it's such a low RPM deal. So that's basically our course of action for machining. I will try to walk you through that step by step, and the next time we come back here, the next segment of the video, we should have this over in the other shop starting the machine work on it.